Hello everyone, welcome to Civil Engineering and Stuff. And in today's video lecture, we are going to discuss about depth of water stored in root zone, and we are going to do few numerical on this topic. All right. So in the previous lecture, we have discussed about the moisture content of soil, and there we have discussed that the soil moisture that is available in the soil are generally three types. That is, we have the gravity water, we have the capillary water, and then we have the hygroscopic water, right? And there we have discussed about the gravity water, that is, it is the excess quantity of water that is available in the soil, and if free drainage provision is there, if there is any free drainage provision, then this gravity water drains out of the soil, and what remains in the soil is this capillary water and the hygroscopic water. And together, this total quantity of moisture content is what we have discussed as the field capacity. Right, we have discussed this in the previous lecture, and we have also discussed about the available moisture content in the soil and readily available moisture content of soil. Right, and we have discussed that this is around 80% of the available moisture content of soil. And we have also discussed about the wilting point moisture content. It is that small quantity of moisture content that is available in the soil, and when the moisture content of soil reaches to the wilting point, so basically this much amount of water is not sufficient enough for a soil for a crop to sustain its growth, right? And what happens is that if the moisture content reaches to the wilting point, your crop will wither out, right? Your crop will die because not much quantity of moisture content is available in the soil for its sustenance, right? So we have discussed about these kind of moisture content in the soil in the previous lecture. If you haven't watched that video lecture, I highly recommend to first of all watch the video lecture on this topic, because today we are going to find out the mathematical expression of for the depth of water stored in the root zone, where these technical terms will be used exhaustively, right? And we are going to do a few numericals on this, so it's better you have a clear understanding about these topic first, like what is the moisture content, what is the optimum moisture content, what is readily available moisture content, what is building point, what is field capacity, right? And what is the frequency of irrigation that is required in the soil. Okay, in this lecture we are going to find out the mathematical expression for the depth of water stored in the root zone, and from there we are going to find out the mathematical expression for the readily available water, depth of water available, and water that is not readily available to the soil. All right, so let's continue with this topic. Let's say we have a crop, and this crop has the root zone. The roots of this crop extend to a depth d, right? The root of the crop extends to a depth d. For the sake of discussion, we are going to consider a 1 meter square area, right? So let us consider a 1 meter square area, 1 meter square area of soil, right? We are going to consider 1 meter square area of soil. That is, let's say, for the sake of discussion, we are taking a certain area, right, of soil section, area A. And in this area, D is the depth of root zone. D is the depth of root zone up to which D is the depth of root zone up to which root of a plant extend. Root of a plant, root of a plant extend. The roots of the plant extend to a depth D. And since we have soil, a certain volume of soil, right? So of course there will be some kind of moisture that will be there in the soil, and therefore let's say FC is the field capacity. FC is the field capacity. Gamma W is the unit weight of Gamma W is the unit weight of water, and gamma is the unit weight of soil. The moisture in the soil extend to a depth dw soil. If we want to quantify the amount of moisture that is available in the soil in terms of depth, then dw is the depth up to which the moisture is available in the soil. So we have depth d, fc field capacity, gamma w unit weight of water, gamma unit weight of soil, and dw is the depth of moisture available in the soil. So we have discussed about the definition of field capacity. Field capacity, we have discussed field capacity is the weight of water. Field capacity is the weight of water in certain volume of soil, in certain volume of soil, to the weight of soil having same volume, weight of soil having same volume. This is the ratio by which we have defined the field capacity in the previous lecture, right? Weight of water in certain volume soil. That is the water that is there, the moisture that is there in certain volume of soil. Area is 1 meter square area. Area is A, and up to depth D. So field capacity is the weight of water stored in certain volume of soil to the weight of soil having the same volume. That is the weight of soil having the same volume. So this FC is represented by weight of water divided by the weight of soil having the same volume, right? And we know that the unit weight is defined as the weight upon volume. So we can use this expression here. So we can write it as weight of water. This means volume of water into unit weight of water divided by volume of soil, volume of soil into unit weight of soil. Since we are taking a certain specific area of soil section, so this volume can be written as A into depth of water that is stored in the soil into gamma W divided by A into depth of root zone into unit weight of the soil. Since area is same, this can be cancelled out. So that is the field capacity in is now equal to field capacity is now equals to depth of water into unit weight of water divided by depth of root zone into gamma, right? So what is the depth of water that is stored in the root zone? The depth of water will be gamma divided by gamma W into depth of root zone into field capacity, right? This is the expression for depth of water that is stored in the root zone. This is the expression for depth of water that is stored in the root zone. Through the same expression, we can find out the depth of wilting point moisture content of the soil, and this will be gamma by gamma W into depth of root zone into the wilting point moisture content of the soil, right? So wilting point depth up to which the wilting point moisture content lies is d phi is equals to gamma pi gamma W into d into phi. Similarly, the optimum moisture content depth will be equals to gamma divided by gamma W into depth of root zone into the optimum moisture content of the soil, right? Into the optimum moisture content of the soil. These are the expressions for the depth of moisture content for the various parameters. So we have discussed previously, like in the last lecture, we have discussed about the readily available moisture content. If we want to quantify in terms of depth of water that is readily available, readily available depth of water. What is the readily available depth of water? So that we have discussed is dW minus dm naught, right? dW minus dm naught. So that will be gamma by gamma W into D into Fc minus m naught, right? Simple. We have the depth of water up to which the field capacity is there. We have depth up to which the optimum moisture content level is there, right? So through this we can find out the readily available moisture content depth, right? Similarly, depth of water or depth of the depth of available water will be moisture content field capacity minus the melting point moisture content, right? That is the total depth of moisture content, total moisture content that is available in the soil. So depth of water that is available will be equals to dW minus d phi. So through this we have gamma by gamma W into D into Fc minus phi, right? Then we have depth of water, that is depth of water not readily available, depth of water not readily depth of water not readily available. So that will be the optimum moisture content minus the wilting point moisture content, right? In terms of depth, we have dm naught minus d phi, right? So this will be gamma by gamma W into d m naught minus phi. Okay, so these are the expressions, three main expressions that can be derived through this. That is the depth of water that is readily available, depth of available water content, and depth of water that is not readily available. All right, these are the three expressions that we can derive from here. All right, so for better understanding, let us do a numerical on this. All right, the question is, after how many days will you supply water to ensure sufficient irrigation of the given crop? If the field capacity value is 28%, permanent wilting point is 13%, dry density of soil is 1.3 gram per cc, effective depth of root zone is 70 centimeter, and daily consumptive use of water for a given crop is 12 mm. Alright, so since we have discussed all the terms except the daily consumptive use, let me just in brief tell you what is daily consumptive use. Daily consumptive use means consumptive use is the quantity of water that is utilized by the crop. So daily consumptive use is the water utilized by crop, the water utilized by crop for its growth or for to meet its evapotranspiration rate, for its growth or to meet its evapotranspiration need on daily basis. On daily basis, right? That is daily 12 mm of water is being utilized by the crop to meet its evapotranspiration need or for its growth. All right, this is the meaning of daily consumptive use. Now let's get back to the question. Now the question says we have to find out the watering interval of the crop. After how many days will you supply water, right? That is, what is the watering interval of crop, right? We are given the field capacity of soil, that is the overall moisture content of soil, permanent wilting moisture content. We are given the dry density, effective depth of the root zone to which it extends, and we have been given the daily crop requires 12 mm of water, right? The crop requires 12 mm of water, right? So to find out the how many days after how many days the watering should be done, that is the watering interval of crop, we need to find out the readily available water, right? We need to find out the readily available water depth of water that is readily available, Why do we need to find out? Again, we have discussed in the previous lecture, right? This readily available moisture content, we always want we always want our soil moisture content to be at readily available moisture content, because this is the quantity of moisture content that is easily available. The roots of the crop can easily extract this moisture content and fulfill their whatever water requirement of the crop is, right? We always want our crops to have the moisture content till readily available moisture content level, right? So basically what we have to do is we have to find out the depth of water up to which the moisture content should be readily available. All right, and we have discussed the formula. The readily available depth of crop is equals to the field capacity minus the optimum moisture content capacity, gamma by gamma w into d. All right, so if you look into the question, if you look into the question, we have been given gamma, unit weight of soil. We have been given gamma, the unit dry density of the soil. Gamma w is a standard unit, we already know, right? D is the depth of root zones, right? And we have been given the effective depth of root zone, right? We have been given field capacity, right? We have been given field capacity, moisture content, and we have been given optimum moisture content of the soil, right? We have been given optimum moisture content of the soil. If I want to plot these values, we have been given field capacity. Field capacity is equals to, we have been given field capacity value. The field capacity value is, the field capacity value is 28%. Field capacity value is 28%. We have been given the permanent wilting point, that is 13%. We have been given permanent wilting point, that is 13%. Phi is equals to 13%. We have been given phi is equals to 13%. Right. Just for the sake of easiness, I'm again going to write formula here. Depth of readily available moisture content is gamma by gamma w into d into fc minus m naught, right? So if you see, we have been given the value of gamma, we have been given the value of gamma w, we have fc value, we don't have, right? We do not have optimum moisture content level available to us. So to find out the optimum moisture content level of the soil, like this is what we have to find out. All right, and then all we have to do is we have to put the values and get the answer. So first of all, let us see what is the overall available moisture content of the soil. What is the overall available moisture content of soil? This is the overall depth of available moisture content of soil. This is the overall available moisture content of soil. So that it will be 28 minus 13. 28 minus 13. So that will be 15% is the available moisture content of the soil, right? This is the overall depth of like moisture content available in the soil, right? And we know that the readily available moisture content, readily available, readily available moisture content of soil is 80% of the 80% of the available moisture content of the soil, right? So the readily, since we are not given the value, so we will assume a standard data that the readily available moisture content is 80% of the available moisture content of the soil. So that will be 80% of 15%. That will be 80% of 15%. So solving it, 0.80 of 15%. So this will be 12%, right? This will be 12%, right? So the readily available moisture content is 12%. All right. So if you want to showcase here, the readily available moisture content is 12%. All right. So what is the optimum moisture content level or the depth of optimum moisture content level available. What is the total depth of optimum moisture content available in the soil? This much. So the available moisture content on the soil, the available moisture content of soil will be 28 minus 12, right? This will be 28 minus 12. So that will be equals to 16%, right? This is the available optimum available moisture content, right? Or to just to avoid any confusion, I'll just write this is the optimum moisture content of the soil. All right, that is 16%, right? So this is the optimum moisture content of soil, that is 16%, right? We have field capacity moisture content 28%, optimum moisture content level M naught 16%, right? So since we have this value, now all we have to do is we have to put the value in the formula here, right? So we have gamma, that is the dry density of soil. We are given 1.3 gram per cc, right? So we will put 1.33 gram per cc. Since it is in gram per cc, so gamma W will be 1, right? Depth of root zone, right? The depth of root zone, right? So the depth of root zone we have been given 70 centimeter. So we are going to put 70 centimeter. Then field capacity moisture content. Field capacity moisture content is given as 28%, right? It is given as 28%. So we are going to put it as 0.28 minus optimum moisture content, that is 0.16. 0.16. All right. So solving it, the answer will be 10.92 centimeters available, right? This is the depth of water that is readily available in soil. And like we want the water to be at this level, right? Every time. So we don't want the water to go below this. If as soon as in number of days the water goes below this, then we'll again do the watering, right? So now let us find out the interval of watering. Like after how many days we have to supply the water. So the consumptive use is given as 12 mm, right? The consumptive use Cu is given as 12 mm, right? Since here the unit is centimeters, let's convert this also into centimeters. So this is 1.2 centimeters. Okay, 1.2 centimeters. All right. So this 1.2 centimeter of water is utilized is utilized by crop in how many days? In one day, because it is a daily consumptive use, right? 1.2 centimeter of water is utilized by crop in one day, right? So 1 centimeter of water is utilized by crop in how many days? 1 by 1.2 days, right? So this 10.92 centimeter, this 10.92 centimeters of water will be utilized by crop in how many days? 1 into 10.92 divided by 1.2 days, right? So on solving it, you will get 9.1 days, right? So this 10.92 centimeters of water will be utilized by the crop in 9.1 days, that is almost similar to 9 days. It will be utilized in 9 days, right? So this means after 9 days we have to supply the water so that the depth of water is there at the readily available moisture content level depth, right? So, so we can say that hence after 9 days, after 9 days, water should be supplied, water should be supplied to the given crop. Water should be supplied to the given crop. Okay, water should be supplied to the given crop. Okay, so this is how we have to find out the watering interval of the crop. All right. I hope this question is clear to you. If you have any doubt, you can always ask in the comment section. All right. Let's do another question. Let's do another question. And the question is that we have been given certain data that are there for a healthy growth of crop. Right. Following data pertains to the healthy growth of the crop. We have been given the field capacity value. We have been given the permanent wilting point moisture content. We have been given the gamma of soil, that is 1300 kg per meter cube, right? In the previous question it was in gram per cc. Right now we have in kg per meter cube. Depth of root zone is given as 700 mm. Daily conservative use of water is 12 mm. We have been given additional information that for healthy growth of crop, moisture content must not fall below 25% of the water holding capacity between field capacity and permanent wilting point. So here also we have to determine the watering interval of the crop in days. All right. All right. Again, let's look at the question. So we have been given the field capacity, we have been given the permanent wilting point, gamma of soil, depth of root zone, daily conservative use. This is important that the for healthy growth of the crop, moisture content must not fall 25% of the water holding capacity between field capacity and permanent wilting point. Right. So since we have to find out the watering interval, this means we have to find out the readily available moisture content, right? Nothing new in this. We have to find out the readily available moisture content. This means that to find out the readily available moisture content, let's first of all look into the data that are given. Let's first of all visualize the data that is given to us, right? The field capacity of the soil is 30%. The permanent wilting point moisture content is 11%. Is 11%, right? For healthy growth of crop, the moisture content must not fall below 25% of the water holding capacity between field capacity and permanent wilting point. For healthy growth of crop, that is the optimum moisture content of the crop. The optimum moisture content of the crop must not fall below 25% of the water holding capacity between field capacity and permanent wilting point, right? So the optimum moisture content of the crop must not fall below 25%, 25% of the water holding capacity between field capacity and permanent wilting point, right? All right. So the moisture content should be greater than this value. How much greater? Greater than the wilting point, right? So this means whatever be the value that we get from this expression, it should be this much above the permanent wilting point. All right. It should be this much above the permanent wilting point. So plus 5, or 5 in this case is 11%. So we have 25% of 25%, we have 25% of 30 minus 11 plus 11%, right? I'll again repeat. The question says that the moisture content must not fall below 25% of the water holding capacity between field capacity and wilting point. 25% of whatever the moisture content that is stored in between, right? That is the value that we get, but the optimum moisture content must not fall below this. This means it must be above this wilting point. That's how we are going to get this moisture content level. right? So this will be 4.75% plus 11%. Okay, so the value will be 15.75%. So the M naught value will be 15.75%. All right, this is the optimum moisture content level. Right. So since we now have M naught, so the depth of water that is readily available, the depth of water that is readily available, we know the formula. The formula is gamma by gamma W into depth of root zone field capacity minus M naught. Right. Gamma we have been given 1300 kg per meter cube. 1300 kg per meter cube. Since it is in kg per meter cube, so this will be 1000. Gamma W of water in kg per meter cube is 1000 kg per meter cube. The depth of root zone will be 700 mm. All right. Field capacity value is 0.30 and M naught value is 0.1575. Okay. So on solving it, the value that the depth of water that is readily available will be 129.675 mm. 129.675 mm. All right. So this is the depth of water that is readily available. Consumptive use of or the daily consumptive use of water is 12 mm. Right. Daily consumptive use is 12 mm. So 12 mm of water is utilized 12 mm of water is utilized in one day. So 129.675 mm of water is utilized in 129.675 divided by 12 days. Okay, so this will come out to be 10.81 days, right? 10.81 days. So let's take it as 10 days only. Why we have not taken 11? Because before 11th day, the level of water will or the depth of water will get reduced, right? So it's better to provide water early than providing water late, because if we would have rounded off, if we would have rounded off to 11 days, this would have meant that the water has to be provided after 11 days, but but by that time the depth of water would have reduced from the readily available moisture content, right? So that is why we are taking the value as 10 days, right? So we will still have some amount of time left with us. That's okay, right? So for safer side we are taking it as 10 days, right? So the water, so we have to say hence after 10 days, after 10 days water should be applied to the crop. Okay, water should be applied to the crop. Okay, so this is how the numericals on the depth of water stored in the root zone are done. So see, if this you can like put it in the formula also. Like it's a simple unitary method, nothing much in a formula. But if you want to put it in the formula, the water or the frequency of irrigation is can be represented as d dash w divided by cu. D dash w is the depth of water that is readily available. Okay, d dash w, we can say this is as d dash W, right? Just in case if you want to put it in terms of formulas. Okay, so this is these are the expressions for the various kind of water that depth of various kind of water that are stored in the root zone. The numericals I hope are clear to you. Try to do the numericals by yourself. If you have any doubt, you can always ask in the comment section. Okay. All right. So that's it for this video. I hope the lecture is useful to you. If so, like the video, post your doubts or your views in the comment section, and subscribe to the channel for more views like this. Thank you for watching. Have a nice day.